Every few years, a headline appears somewhere claiming physicists have found a new path toward time travel, a strange new equation, a clever new loophole. And every single time, if you follow that headline far enough, all the way down to the actual mathematics underneath it, you find the exact same wall waiting at the bottom, quietly, patiently, refusing to move. I have spent a great deal of my career studying exactly where that wall comes from, and I want to walk you directly up to it today, because I think most explanations of time travel skip past the real obstacle entirely. It is not that Einstein's equations forbid moving through time. In certain very specific mathematically valid situations, they genuinely do not. The real obstacle is something else entirely, something closer to a missing ingredient than a missing idea. Today we are going to find out exactly what that missing ingredient is, and why building it may be one of the hardest problems the universe has ever handed us. And if you want to keep exploring the honest, unresolved edges of physics with me, make sure you are subscribed, because I think the real reason time travel remains out of reach is far stranger than simply not having invented the right machine yet. Let us start with the part of this story that genuinely surprises people. Einstein's general relativity, the same theory that gives us black holes, gravitational waves, and the bending of starlight around massive objects, also permits mathematically certain exotic shapes of space-time that loop back on themselves, paths that a traveler could follow forward through time and eventually arrive back at an earlier moment than when they began. Physicists call these closed time-like curves, and their mere mathematical existence is not really in serious dispute. The question was never really whether the equations allow it. The question is whether nature actually provides the raw materials required to build one. Picture an architect handed a set of blueprints for a magnificent bridge spanning an enormous, otherwise impassable canyon. The mathematics of the design is flawless. Every angle, every support beam, every calculation checks out perfectly on paper. There is only one problem. The blueprint calls for a material that, as far as anyone has ever been able to determine, does not actually exist anywhere in nature, in any usable quantity at all. That missing material in the physics of time travel has a name. Negative energy, sometimes called exotic matter, a substance whose energy density is less than zero, capable of doing something ordinary matter simply cannot. Holding open exotic shapes of space-time, like wormholes or certain theoretical warp configurations, instead of allowing them to instantly collapse under their own gravity the moment they form. I want to be very precise here, because this is where a lot of explanations get sloppy. We are not entirely making this up. A real, measurable hint of negative energy does exist, discovered in a laboratory effect called the Casimir effect, where two metal plates placed extremely close together in a vacuum experience a tiny, genuine attractive force caused by a measurable dip in the local energy density of empty space itself. This is not speculation. It has been confirmed experimentally, repeatedly, since the 1990s. But here is the devastating part, the part that turns an exciting discovery into a wall nobody has ever found a way around. The amount of negative energy produced by the Casimir effect is almost unimaginably small, confined to a gap between plates measured in nanometers. To hold open even a small traversable wormhole, physicist Kip Thorne and his colleagues calculated that you would need a quantity of negative energy so vast that, by some estimates, it would rival or exceed the total mass energy of an entire star. Concentrated in exactly the right configuration, sustained for exactly the right amount of time. Picture trying to span that same impassable canyon using nothing but grains of sand when the blueprint specifically calls for solid steel. You have not been given the wrong idea. You have been given the right idea in a quantity so catastrophically insufficient that the gap between what you have and what you need might as well be infinite. This is not simply a matter of needing better engineering either, and I think this detail deserves real attention because it is so often missed. In the 1970s, and again more rigorously in later decades, physicists Larry Ford and Thomas Roman derived something called quantum inequalities, mathematical restrictions built directly into quantum field theory itself, that limit how much negative energy can exist in a given region, and for how long before ordinary positive energy is required to balance the books. These are not simply practical limits. the kind better technology might someday overcome. They appear to be restrictions woven directly into the deepest mathematical structure of quantum physics itself, functioning almost like a cosmic accountant, refusing to let anyone borrow negative energy without an extremely strict and extremely unfavorable repayment plan attached. Picture walking into a bank and discovering that yes, technically negative balances are permitted on paper, but the moment you actually try to withdraw a large one, an automatic unbreakable rule kicks in, demanding it be repaid with interest almost immediately in a way that makes any large, sustained negative balance functionally impossible to maintain for any meaningful length of time. So here is where the first part of our journey leaves us. General relativity hands us a valid blueprint. The universe hands us a genuine, if microscopic, confirmation that the necessary material is not pure fantasy. And then quantum field theory itself steps in and appears to slam the vault shut, refusing to let that material ever exist in the quantities the blueprint actually requires. This raises a question I think is far more interesting than simply asking whether time travel is possible. Why would the universe go through the trouble of allowing the blueprint to exist at all, in principle, only to seemingly forbid, at every practical turn, ever gathering the materials to build it? That is exactly where we are headed next. Stay with me. We discovered that time travel's real obstacle is not a missing idea, but a missing ingredient. Negative energy, restricted so severely by the deep mathematics of quantum field theory that gathering enough of it may be functionally impossible. But I left you with a genuinely strange question. Why would the universe allow the blueprint to exist at all, only to forbid, at every practical turn, ever gathering the materials to build it? Stephen Hawking offered an answer to exactly this question in 1992, and I think it remains one of the most elegant, quietly unsettling ideas in modern physics. He called it the chronology protection conjecture, and its core claim is disarmingly simple. Perhaps the universe does not need to forbid time travel through some single obvious law. Perhaps it protects itself automatically, the moment anything gets close enough to actually succeed. Picture, for a moment, an enormous dam holding back a reservoir of water. As engineers work to open a small channel through it, cracks begin to form near the point of greatest strain, growing wider and more severe the closer the channel gets to actually breaking through, until, eventually, the dam collapses entirely, sealing the breach before it can ever fully open. Hawking's calculations suggested something remarkably similar might happen to any closed time-like curve as it neared completion. As space-time approaches the exact configuration required to loop back on itself, quantum fluctuations, ordinary vacuum energy of exactly the kind we discussed in an earlier journey together, appear to pile up and intensify precisely at that critical point, growing without limit as the loop nears closure, according to several independent calculations performed by physicists studying this exact scenario throughout the 1990s. In other words, the very act of almost building a time machine may generate a wave of destructive energy severe enough to destroy the machine itself, an instant before it could ever actually be used. Not through some external intervention, not through some cosmic police force, simply through the deep mechanical mathematics of quantum fields, reacting automatically, self-referentially, the moment reality edges too close to a genuine paradox. This connects directly to something else worth understanding clearly, because I think it deserves more attention than it usually gets. Even setting aside the energy problem entirely, even imagining some future civilization somehow solving it, there remains a deeper, logical obstacle sitting underneath everything we have discussed so far. The grandfather paradox, the simple devastating scenario where traveling backward allows you to prevent your own existence, creating a contradiction physics has never found a clean, universally agreed way to resolve. Physicist Igor Novikov proposed decades ago that the universe would simply never permit a genuine contradiction to occur, that any attempt to create one would always, through some chain of events, however improbable, quietly fail. Others have proposed that any successful trip backward would simply branch reality into a separate parallel timeline entirely, leaving the original untouched. Neither idea has ever been tested. Neither idea commands full agreement among physicists today, and that lack of resolution is itself telling. When a phenomenon remains this deeply unresolved, this resistant to a single clean answer, after decades of some of the most capable minds in physics working on it directly, it is often a sign that we are pressing against something more fundamental than a simple engineering challenge. Let me give you one final way to feel the true scale of what we are actually asking for here, because I think numbers make this more real than words alone ever could. Even the most optimistic theoretical proposals for stabilizing a traversable wormhole or sustaining an Alcubierre-style warp bubble, another space-time shortcut requiring the exact same negative energy ingredient, estimate energy requirements ranging from the mass energy of a small planet to, in some early calculations, an amount exceeding the total mass energy contained in the entire visible universe. Later refinements have narrowed this considerably, but even the most generous, most optimistic modern estimates remain firmly beyond anything resembling a civilization's available resources today or for the foreseeable future. Picture a recipe requiring not simply a rare ingredient, but a quantity of it larger than every kitchen on Earth combined could ever hope to gather, even if that ingredient existed in unlimited supply, which, as we established in the first part of this journey, it very much does not. This is the true shape of the obstacle standing between us and a working time machine. Not stubbornness, not a lack of imagination. A demand for resources that appears to sit permanently, structurally beyond reach. I want to leave you with something I think is easy to overlook, buried underneath all of this discouraging mathematics. The fact that time travel appears functionally impossible does not mean the universe is being needlessly cruel or restrictive. It may mean something closer to the opposite. A universe where causes reliably precede their effects, where the past remains fixed and the future remains open, where your own existence cannot be casually unraveled by anyone with sufficiently advanced technology. Is a universe stable enough to actually produce galaxies, stars, planets, and eventually minds capable of understanding any of this at all? The same deep structure that seems to forbid time travel may be the very same structure holding everything else together. So where does this leave us at the end of our journey together? General relativity hands us a mathematically valid blueprint. Quantum field theory refuses to supply the material required to build it. And should any civilization ever come close regardless, chronology protection may simply erase the attempt before it can succeed, the dam sealing its own breach the instant before it fully opens. Perhaps time travel is not impossible because nature failed to consider it. Perhaps it is impossible precisely because nature considered it very carefully indeed and decided the cost of allowing it would be too great for anything else to survive. Exploring the honest, unresolved edges of what physics does and does not allow is exactly why I do this work and exactly why I wanted to walk through this particular mystery with you. If this changed the way you think about every time travel headline you will ever read again, then make sure you are subscribed so we can keep exploring these questions together. Tell me in the comments, honestly, if that missing ingredient were somehow found tomorrow, would you actually want to see someone use it? Until next time, keep looking up and keep asking what the universe might be quietly protecting.